bit. I'm going to do a presentation on the current state of the nation in the UK. There's three key topics I want to cover here, and they are future market opportunities in a general global sense, where we are in the UK today, quick kind of whistle-stop tour of the capabilities in the UK, and then thirdly, I think it's worth, especially unfortunately we couldn't have the minister this morning because of some kind of competition going on in Westminster at the moment. So I'm going to try and do a brief summary of what actually has the UK government done in the last year or so, and also connected with that, what is TechWorks doing at the moment, and how are we trying to help the industry. I started with this. I like to try and start with some kind of high visionary kind of pitch. And this is something I have said to a number of people, including government a number of times. We get really excited about all of these technologies I've put little icons of on the slide here. And I think it's worth also considering that there are some really big drivers, economic, global, societal megatrends, which is why these technologies are emerging and becoming important. And I'm going to read everything on the slide, but we have crazy stuff like the world is becoming hyper-connected. We are digitizing everything. We're kind of creating a digital twin of the planet and the human race. And that's pulling through communications technology, sensor technology, and so on and so forth. And I won't go through the rest of them, but you can see. And of course, we're really excited about AI and machine learning. We're excited about biotechnology, quantum computing, future communications. The asterisks on the slide are because these are the 5 technologies that DCIT and the UK government have got behind as strategic technologies for the UK. And I think they're good choices and they're important and they're right to do that. But by the way, there's a bunch of other stuff too. And my point here is that all of these transformative emerging deep tech technologies that we think are amazing, and I'm a bit of a fan of sci-fi. I think if you want to know what the world's going to look like in 25 years' time, watch some quality sci-fi movies, because you will get a sense of what's coming. And I think in 25 years' time, we won't recognize the world that we live in. It's going to change significantly, and it's going to change because of all these technologies. One of those technologies on the bottom left here is semiconductors. And I think, I'm preaching to the choir here, right? I think you would all agree with me that semiconductors is the one technology which is fueling all of the above, okay? And this is a slide I've used before, but I dropped it in here because I think it's useful to go to the next level down to explain at a more detailed level. If we choose metaverse augmented reality as an example, well, here are the technologies fueling that. And we heard a bit about that earlier from Plessy and Sivers. Let me pick something else. How about future telecommunications? Well, there's a lot of stuff in here, which is about 5G, 6G. It's about smart antennas, even AI used in the antenna array to predict where the beam should be steered in the next 5 millisecond frame. I think that's it's nuts, but people are doing that right now. They're putting AI chips in antennas on the top of 5G base stations. IoT, everything smart, sensors, power electronics is relevant to future telecoms. Optical communications is how you get the data in and out of the masthead. Typically these days in a 5G base station, all of the base station is effectively just a big power transmitter. All of the data flowing into that is across fiber optics, and all the signal processing is done in the cloud, 100 kilometers away. But look, here's the enabling semiconductor technology that's going into all of these things. So, there's a longer, it's a shortened list, but these are the kind of technologies that are pushing into all of this stuff. High-speed digital memory, we understand that. Advanced node CMOS. There's a bunch of other stuff we've been talking about here all day long, right? So I'm going to talk a little bit about the global market, some market data. Most of this, I think, is off the web. This is publicly available data. Where do I start? The WSTS forecast, which comes out of the SIA, we know these numbers, right? It's 526 billion chips in last year. The forecast is for close to $600 billion, chip revenue this year. And you can see the shape of this curve from Statista. which is, still exponential growth in the revenue in the semiconductor industry. Now, this is fueled by new technology, new products, and new markets. So we've had, of course, the smartphone industry. It's kind of a bit boring now, but we've got plenty of other stuff coming on stream. Cars, automotive is turning to a smart car on wheels. So there's some crazy statistic, which is half the value of a car is the semiconductor and software componentry going into that car. Wasn't that way 5 years ago. Moore's law has been responsible to a large extent to fuel a lot of this. And I think it's important to think about Moore's law. It's not just about high performance, right? If you can put more smaller transistors onto the same size of die, it could be that you can do more stuff more quickly, high performance. It could be that you can make more chips cheaper and push the volume. It could be that you therefore, because you're making more smaller chips on a die, and therefore each chip is cheaper, you can push them into smartwatches, fitness trackers. Even, for example, Nike now have a model of trainer which has got a Bluetooth sensor built into the trainer, so you can track how well you're jogging to the shops on your smartwatch. And all of this stuff is kind of disposable, right? So I could talk even more about my experience in the communications and IoT industry, but it's a race to the bottom in many cases in some of these commodity sectors. And I think that leads me on to this interesting thing here, is that if you look at the higher volume segments of the semiconductor industry, it becomes extreme high volume and extreme low cost. And that's what we see in the smartphone industry, for example, where you get such an increasing pressure from OEMs on the margin, on what they're paying for the silicon. The silicon companies, it's kind of like an arms race. They want to be winning that billion unit a year business with Apple or Samsung, so they go for it. Once they've got it, they struggle to make ends meet, and if they lose it, they're potentially out of business. And in many cases, certainly as an SME, that's not a business you really want to be in. But the good news is there's a long and diverse tail of medium to large volume markets that have a better value recognition. So, for example, in automotive, in industrial, in medical applications, you can get a decent margin for a quality product. And actually, there's probably 10 competitors in that market, which is good. It's a healthy, buoyant market. It's not you versus the 100-pound gorilla in Silicon Valley. So, and I wanted to make that point, as people have noted today, Moore's law, I'm not going to say Moore's law's dead. It's got a bit left in it, but I think it's on its way to retirement. I'll come back to that in a moment. So here's another market slide. The point of showing you this is we can see a bit of a breakdown between memory devices, which is a big segment. Hang on, reading this up. Oh yeah, memory devices at the bottom. Logic devices are kind of custom ASIC for specific application purposes. And then we have analog IC, which is a nice steady component here. And then we have quite a large piece of MPU and MCU. Now, I think you can break this into, of course, Intel processors, NVIDIA processors, although that could also be part of the logic device business. But there is a large business in microcontrollers, and microcontrollers consist of a microprocessor plus a bunch of custom logic, and they really are the backbone of the application-specific standard product business, which is everything from IoT devices to the kind of Bluetooth controller chip that's inside this watch to many, many other industries. This is another interesting slide I like, or two slides actually. And what this is showing, two things this is showing. One, how if you look at the top 10 vendors of semiconductors, actually NVIDIA, Intel, Samsung, Broadcom, Qualcomm, AMD, SK Hynix, they really are that extreme volume piece of the industry. When you add that up, it's 50% of the global revenue number. So actually, and when we get to 2030, where we're talking about $1 trillion worth of semiconductor industry, well, actually, there's $500 billion worth of semiconductor industry is that long tail, right? And you'll remember that a few years back, TI, Infineon, ST may have been up the top here. They're not anymore. But actually, they have become a large piece of that long tail. If you look at the ST Microelectronics product catalogue, it's yay thick, because they make a whole range of different ASSPs for a range of different markets. And some of those are some really valuable, nice pieces of business. The other side to this slide is this, which shows the foundry perspective. So obviously TSMC is the largest foundry on the planet. Interestingly, if you add up Apple, NVIDIA, Broadcom and Qualcomm, that's half of TSMC's business. So it's kind of sobering to think if suddenly Apple and NVIDIA go out of business, TSMC's in a lot of trouble. The other perspective on that, of course, is if you're an SME in the UK trying to get fab slots at TSMC, good luck with that, because they're likely to be more worried about Apple, NVIDIA and Broadcom than they are about you. Okay, another market slide. The purpose of this one really is just to kind of highlight some of these end market segments. So if we look at automotive and industrial, and we look at communications and some of the computing, obviously in that computing piece is going to feature Intel and increasingly NVIDIA in cloud applications, but some of that is more embedded compute, some of the ST Micro stuff, some of the Infineon stuff. Memory is a very commoditized market dominated by a few players, as I mentioned earlier, and so memory is a large piece of that computing and data storage segment. But as I say, some of these numbers are quite interesting for companies in the UK, I think. Okay, so my point is there's quite a lot of business to go after, in the next 5 to 10 years. I won't read the list again, but novel. I think there's opportunity in novel AI and machine learning. So I'm talking here about power optimized neuromorphic computing, new architectures, not using a big, heavy, powerful GPU to do something that arguably could be done by an optimized accelerator chip. And we have a bunch of startups in the UK and some universities working on that one already. We've talked about quantum and optical compute, some really interesting startups in the UK doing this. I think the UK has a really good history and some good technology around sensing. MEMS and LiDAR in particular we have some strengths in, but we don't have the rest of the supply chain, and that's something we need to work on, taking that IP and innovation and or low volume pilot silicon and pushing it into the supply chain to make the LiDAR systems that would go not just into cars, but actually into industrial process, robotics, and maybe some consumer applications even as well. Okay, so moving on from there. So here's where we are today in the UK. This is data that we have pulled together. Obviously, almost all of those 27 chip fabs are members of NMI, so we know them all quite well. And if you look at what we have in the UK, as I mentioned, we have quite a strength in MEMS, sensors, photonics, mixed signal, MOSFET, power devices, diodes and MOSFETs, silicon carbide, of course, RF and microwave ICs. Actually, we have that in silicon around several fabs in the UK. Obviously, I'm talking legacy node silicon, and we also have compound semiconductor across that as well. In terms of design, we have roughly around 160 design companies. We have something like 200 plus design groups or centres across the UK. A lot of those are startups, many are SMEs, some of them are quite large. Of course, Imagination and ARM are designing semiconductor technology as well. And really, that's across everything, right? I mean, GraphCore, many of you will know about GraphCore, fabulous startup in Bristol. They took probably the most challenging thing they could try and do would be to take on NVIDIA, and they have. And actually, from a technology and a product standpoint, they have a really compelling proposition. Worth Googling them if you haven't already. And then we have packaging as well. We have about 10, 11, 12 packaging activities and companies across the UK. Not advanced packaging, as we heard earlier. We're talking about that. We in TechWorks NMI are looking to pull together a working group on advanced packaging. If you want to know more, talk to me or Adam. But I think there's a big opportunity for the UK here. But we do have a range of packaging capability. And then this point at the bottom here, I think it's interesting if you look across the UK at the kind of silicon nodes we use. We do have some advanced silicon where, of course, we're working with TSMC, IMEC, and others at the advanced level. But we have a lot of activity in 40, 65, 90, even 180. Because when we look at MEMS and photonics and sensors, even some of the MOSFET stuff, that is the appropriate node to use for that technology. And there are companies in the UK, as we've heard, that are selling MOSFET technology into products made by the fruit company in Cupertino, for example, which is a pretty good testament to what we can do in the UK, I think. Over here, really, this is a slide I pulled together from Yole, which just talks about the compound semiconductor markets going forward. And we cover all of this in the UK, right? And there's a huge range of applications. Even per technology, as we heard earlier, gas isn't just about LEDs. It goes across a range of different applications. Same for indium phosphide, GaN, and SiC. Okay. I won't talk through this slide. It speaks for itself. We have a number of clusters, and those clusters have certain strengths. But I think it's clear that in the UK, we have capability across the whole country. We have a lot of fab capability in Scotland. We have, of course, the compound semi-cluster in Wales. But we have design, IDM, foundry, and fabless across the whole country. Okay, so in terms of opportunity for the UK, again, there's a few different pictures on the slide here. And I wanted to make this point. Actually, I just dropped this in last night. And it depends what chip you're talking about, of course, and what the process is and what the application fit is. But I think it's interesting to recognize whoever sells the chip is hopefully going to make a decent margin on the chip, right? But the manufacturer, the foundry guy, will make a margin. There are IP royalties to be had in the chip, although typically not as much as the vendor margin or even the foundry margin, to be frank. And then there's test packaging and so forth. There's money to be had across the whole margin stack in the chip. And in the UK, we have ARM. ARM do a great job, and they make an IP royalty. There's a lot more money to be made across the whole margin stack in that silicon. We have innovation, we have IP, and we have manufacture as well. I think silicon is not going away anytime soon, but the interesting area of silicon, I think, is as described here. It's not just about trying to get to 1 nanometer. There's new compound materials, which I'm not going to talk about because my friend Edmund's going to talk a bit more about that later, I think. I'm not even going to try and pronounce some of these, but there's plenty more compound coming down the track, never mind what we're doing today. So there's plenty of innovation to be had. Photonics, I think, is really important, and photonics needs compound and silicon, right? There's a lot of interesting silicon photonics going on if you look at, for example, Southampton, Cornerstone. Power compute, 3D integration, chiplets is really important. That's obviously a key component of what happens next as Moore's Law goes into the retirement home. And I think it's really important, especially given the breadth that we have in the UK, to think about how we can bring all that together and potentially produce some 3D integration in the UK to show how what we have can be integrated. And we don't really want to be worrying too much about phones and laptops, I think, frankly. The challenge, we need to build up and strengthen the ecosystem that we have, and we've talked about that already today. We need a long-term investment strategy, both from industry and from government. We need to figure out a mechanism to support the need for existing companies to scale up their capex. And we've heard fabs today and in the past talk about how £5 or £10 million can enable an SME fab like Classic or Semifab, for example, who are doing great work to scale up. Actually, you're in a market which is growing, which is where you want to be. That's fantastic. You fill the fab to make it efficient. That's what you need to do. And then when you get to 95% utilization, you then need to add more equipment to scale. That's difficult in the UK today. And then supply chains and domestic demand is important, especially in the geopolitical situation we face today. And then skills, of course, are important. And then we need to invest across the industry, not just in startups. I'm running out of time, so I'm going to stop there and skip on to the next slide, because I wanted to say the government isn't just sitting there, it is doing something. So DSIT have a team which is 20 plus people today. I know that the minister, who is now obviously not the acting minister at the moment because of the election, the minister understands what needs to be done and is engaging with industry, and we can't ask for more than that. And within the DSIT team, they have a domestic team and they have an international team that are working very hard. October 23 last year, they launched the Chip Start program to boost startups in this space. November last year, they worked with UKIB, UK Infrastructure Bank, to re-clarify what UKIB should be investing in, and semiconductor manufacturing is now part of what they do. They're focused on Series D, which is, they need to do more, but it's something. Pragmatic, as you know, benefited from that. February 24, EPSRC invested in 2 innovation and knowledge centres in Bristol and Southampton. In March 24, as you heard, we gained access to the joint undertaking in Europe. May 24, the Semiconductor Institute was announced a couple of weeks ago, and that is intended to be an independent institute with government support that will bring together government, universities and industry to support the strategy and to support the industry. So I'm looking forward to being able to move forward on that once the election is out of the way, and they are very busy organising trade discussions and missions. And lastly, from our, UK semiconductor infrastructure, I forgot about that. Many of you are aware of this, and many of you ask questions about this. Very briefly, it is still there. It's being looked at and engaged and discussed within government. There were 5 key work packages. Again, this information is public knowledge. It's on the IFM website. I think it's on our website as well, and it's on the DSIP website. But just to recap, the 4 infrastructure work packages were around should we and what should it look like do in terms of silicon prototyping and pilot volume. Work package 2 was around what kind of advanced packaging capability could we develop and what should it look like. Work package 3 was around can we develop some open access to compound foundry in the UK, leveraging what we already have, which would make sense. Work package 4 was around design and IP tooling, where you can see the chip start as a kind of initial dip the toe in the water to see does this work. And chip start program, if you're not familiar, is incredibly promising in terms of what they've achieved so far. And then work package 5 was there were recommendations in that report that there needs to be a strategic coordination capability at a national level, which is the institute and the government have already started to move forward on that. So that's that. And then from a TechWorks perspective, we launched, the trustworthy AI SIG is less relevant, I think, to today. Power Electronics UK, we're working with a group of industry people to relaunch this. This used to be something we did a few years ago. It kind of fell by the wayside as everybody got motivated and focused on driving the electric revolution. We're now bringing it back, not least because power electronics is not just about automotive anymore. Within NMI, we have a working group discussion going around advanced packaging, also on new materials and processing, and also on photonics. And I just wanted to highlight this piece that we have a relationship, as you know, with SEMI. We also have a relationship with Canada's Semiconductor Council, which was something they launched last year. And BASIL actually is the Bulgarian Electronics Association. We have a relationship with them through Glasgow University. And we are working with the FCDO and with DBT and with DSIT to see where it makes sense for TechWorks to also build relationships with other like-minded trade bodies across the world. And with that, I'm not going to go. We have our semiconductor leadership group, I think most of you are aware of, and some of those members were at the number 10 launch of the Institute a couple of weeks ago. And that is me done, I think. Oh, sorry, I forgot. I dropped this in last night. UK Electronic Skills Foundation, if you don't know about them, you should do. Come and talk to me. They're a sister organisation to us, and they're doing a lot of work in industry with universities and with government on the skills agenda. Okay, thank you.